Hello, everyone. Thank you for joining and welcome to our webinar. Today's topic is connectivity strategies to optimize power consumption for IoT-constrained applications. We have a full agenda today and plenty to present, so let's get started. First, we will do the usual bit of housekeeping. Please note that the webinar will be recorded. It is being recorded and will be sent to you automatically at the end. The presentation is available upon request. Feel free to ask your questions in the GUI interface there, the GoToWebinar interface, and we will get to your questions. We've made some time at the end. So place your questions, and if we're not able to get to them, we certainly will in writing afterward. All right, some introductions first. That's me, Patty Feltz, there on the right. And let me move from right to left to introduce our co-presenters today, Nick Hayes, who is product owner in ublox Services. And also we have Neil Hamilton, who is global head of sales for ublox Services. Our agenda, we will give you a little bit of an overview about ublox and ublox Services in general. We will discuss the characteristics of IoT use cases, then various choices and puts and takes for communication protocols. We'll dive into 3 different customer perspectives on this topic: cargo tracking, pet tracking, and community safety. Wrap it up with conclusions, then we'll get to our questions, and I'll jump back in to give you some insight and some things that are next from ublox. So with that, we provide a comprehensive one-stop shop solution. We at ublox, we are offering these solutions that are essential for IoT applications, and those being wireless communication, either via a cellular network or via Bluetooth and Wi-Fi, the satellite-based positioning chips and modules needed for location, and the data services that establish communication and add additional functionality for location and security. That's where we come in with services. So we are a true one-stop shop solution for such offerings, and we're unique in our capability to provide these solutions all the way from silicon to cloud. Just drilling in a little bit more detail. In this webinar, we're going to focus in more closely into the services product center of ublox. Now in services, we aim to make it easy to connect and locate everything. And we offer these services in combination with our products to boost functionality, overcome challenging conditions, and solve problems like complexity, cost, and availability. We are doing this in 3 key areas, and these are from left to right here, the clouds: communication, location, and security as a service. And today we're going to further zero in on the topic of IoT communication, that cloud there on the left, and how making smart selections in connectivity and in protocol can have a vast and significant impact on the power autonomy of IoT devices. So that's a bit of an orientation. And with that, I'll hand over to our co-presenters, Nick and Neil.
Thank you, Patty. Good morning and good afternoon to everyone. Thanks for attending. It's a pleasure to be here. And as Patty says, we're going to be focusing in here on, these connectivity strategies, the considerations around choosing the right technologies, networks, etc., for building low power, constrained devices that are becoming increasingly more popular in all the verticals that we're working on now. And specifically today, we're not necessarily going to cover the short range, the tethered applications using Bluetooth and what have you. There's shared paradigms in maybe the approaches, but we're very much focusing on the low power, wide area side of things, which we think is obviously growing in increasing numbers in terms of the different types of applications we work with around the world with our partners and customers. Now, when we start thinking about IoT, obviously everything's being connected now, and when we start looking at some of the use cases, and we'll cover some of these in more detail specifically for these types of customers, we find there's certain characteristics that we find, and this is very much where we're focusing. The whole solution these days is going to be around a couple of different parameters, payload size being one, whereas when we're really looking at the raw payload size of what we're trying to do, it's typically sensor-based applications with IoT. And these sensors generate generally small payloads. They're trying to get an occasional measurement into the cloud. And so these can range, these are kind of our average ranges really when we look at what we work with, 50 bytes to maybe half a kilobyte. But as I say, that's the raw payload size. I'm going to come on to some kind of key considerations with that alone with Nick shortly. So again, it's about getting small bytes or small package information into the cloud. And again, different applications require different payload sizes. They also dictate different frequencies. So again, you might notice here, we have maybe a larger consolidated payload from something like this condition alarm, part of one of our customers' IoT gateways, that could maybe communicate once a week, a larger payload out to the cloud. Whereas something like a pet tracker, which again, we're happy maybe to charge it more frequently, could be running more continuously, more every minute, every 5 minutes, etc. Now, what we do see in certain use cases is this is great for the run rate business. These are the normal kind of message frequencies we might see for those small payloads. But again, a solution, when thinking about the strategy for your IoT solution or the device you're building, you need to also think about the practicalities of, well, if I need to get new firmware down onto the device, I need to break this mold. I won't be sending a once every day or once every hour. I need instant access to be able to push down a new image onto a device, for example. Or in a pet tracking, or most commonly things like stolen vehicle, stolen bike scenarios, suddenly we might have to go into an alarm state and maybe message every 10, 20, 30 seconds. So you need flexibility in your choice of communications and connectivity options when you're looking at these bigger solutions. Battery life is key, hence everything we're talking around here is around preserving the battery life for as long as possible. We have different types of customers. We have things from supply chain, could range from 6 months, 5 years, 10 years. Certainly with some of the asset tracking and cargo monitoring applications we've worked with, the customers don't want to see again the trackers returning to base. They will have a non-rechargeable battery that will last for 10 years in the field, and send their information once a day about where they are, maybe some additional conditional information as well. So there's a lot of expectation being put on board a battery. Outside of battery passivation and all the other issues that battery chemistries alone bring, it's how do we make sure we're using as little of that energy as possible for the overall solution. And again, it depends, back to the pet trackers here. Obviously, we are used to charging consumables more regularly in our watches and what have you. So again, these are kind of the, these different levers that we have to consider when looking at an overall solution. But what we've really noticed working with more and more of our partners and customers around the world is that when we start looking at low power, regardless of maybe the radio type, but specifically if you start looking at, the cellular based offerings, there is a lot of focus naturally on the module and maybe what type of capabilities it has for a low power wide area network, and we'll come on to that in more detail shortly. But we see that the radio and the antenna, they're really important. They're physically very important components, but they're only one part of the overall power consumption. And we see that a really, to be fair, even more important aspect to consider is the way in which these devices communicate and get their data into the cloud, because that's where we really see the energy being used. And a lot of this depends on your choice of communications protocol. And these have major impacts on battery usage. And so before we move into some use cases and looking in detail at some of the customer experiences and their specific connectivity strategies, we'd like to take you further now into this part specifically, because I think you'd be very interested to learn more here. So Nick, over to you.
Yeah, thank you, Neil. So as Neil says, one of the critical factors to consider when designing your IoT products is what protocol you're going to use for sending and receiving your data. And the choice that you make can have some big impacts in your time on air. We see at sort of one end of the scale, CoAP and TCP, at the other end of the scale, MQTT and MQTT-SN. And what we find in testing is that request and response protocols need more time on air than something like a publish-subscribe protocol like MQTT. So in the communications as a service offer that u-blox bring, we've decided on using MQTT as the main communication protocol for devices. So why did we do that? Well, MQTT is already quite widely adopted in the IoT space. It's quite widely understood, easy to use, it's reliable, it's very lightweight, and it's bidirectional. So it's you can publish and subscribe messages, get messages back to the device for updating settings and so on. In addition, when we're looking at power and bandwidth constrained devices, there's a derivative of MQTT called MQTT-SN, which was designed for sensor networks. And this is further tailored for those types of devices, dealing with low power and low bandwidth especially. So if we look at MQTT-SN, how is it different to standard MQTT? Well, there are three different options that were added to SN. First off is this concept of topic aliasing. So MQTT gives you the ability to have quite deep and rich topic structures for publishing and subscribing to data. But these, of course, require a significant number of bytes over the air. Obviously, the longer and deeper your hierarchy becomes, the more data that takes to register those topics and reference them when you're publishing messages. So MQTT-SN allows you to set up topics on the broker in advance and assign them a simple integer alias. So then when your devices need to use those topics, they don't have to register them themselves and go through that kind of handshake of registration. They can just simply refer to the predefined alias and start working straight away. MQTT-SN also introduces a sleep mode. This allows a device to tell the broker that it's going to go away for a while and that it will check back in. And while the device is sleeping, the broker will maintain that connection state and queue up any messages that are received on topics that the device is subscribing to, so that when the device then checks in again later on, those messages can be delivered to it. And then there's the quality of services. So MQTT, the main version of MQTT has 3 quality of service: 0, which is fire and forget; quality of service 1, which is to deliver at least once; and quality of service 2, which is to deliver exactly once. MQTT-SN introduces another quality of service, -1, which is a blind fire and forget, a pure fire and forget. And in this case, the client doesn't need to be in a connected state in the MQTT sense before it can publish. So if you combine a topic alias with a quality of service -1 publish message, you're getting data out over the air with just one message rather than multiple back and forth, which will save you time on air. So we had a look at what that time on air means. This example here is some tests that we ran using a Cat M1 modem and a 100-byte payload. And we tested with UDP using u-blox's end-to-end data protection. This is a mechanism to secure data using a private key, which is generated in the modem itself. So the u-blox SARA R5 and R422 modules have security services on them, which allow you to generate a root of trust ID that can be used for encryption of this data. We did another test using TCP with the same end-to-end data encryption. We used HTTPS using TLS for the encryption. We did a co-app message using a pre-shared key, and then MQTT-SN using u-blox's MQTT Anywhere service, which is delivered through the thin stream service delivery platform from u-blox. Now, MQTT-SN from u-blox has an added advantage in that the data is transmitted whilst it's going over UDP. It's over a private and secure tunnel. So that data is never exposed to the internet, which means that you can just send plain text from the device. You don't need to worry about doing any kind of encryption at the device level. And what we see there is that your time on air for sending that 100-byte payload, we look at UDP and TCP with the end-to-end data protection. They're quite low, 800 milliseconds, 1,000 milliseconds. HTTPS with the TLS encryption by far the highest. CoAP coming in, much lower, but MQTT again way down with just 397 milliseconds to send that payload. That then obviously transfers into power consumption. So your device is not on air for as long. The modem doesn't have to be powered up so long. And so your power consumption again is quite significantly reduced. So if we were looking at a CoAP with a pre-shared key there with 112, that's reduced down to 45 with MQTT-SN. So as we mentioned, security can have a big impact as well. We saw back on the previous slide how HTTPS with TLS as the security mechanism had a big input. That's over and above just the chatter of that protocol as well. And we see that in terms of the actual bytes over the air, if we're looking at something like MQTT-SN, sending a small payload, a hello world kind of message going over the air with a few overheads brings it up to 26 bytes. If you're sending that same message over HTTPS with TLS as your encryption, that's up to nearly 6 kilobytes, and that has a huge impact on your power, which we'll see on the next graph. So here we did a test looking at sending just a simple hello world 12-byte payload using a couple of different options. First of all, using a 2G modem, where the MQTT Anywhere solution has a USSD data bearer. This is data that's going over the signaling layer of the network. We also did the same test with LTE Cat 1. So this is full LTE using our UDP bearer, and then comparing that with LTE on HTTP, and then finally the secured version of HTTP. And we see that the relative power consumption there with MQTT Anywhere significantly lower, and with HTTPS being just over double what it would be to send that data using SN on the 2G network. But what's really interesting is this graph on the right, where you see the payload inflation. So a 12-byte payload sent over 2G actually is 26 bytes over the air, 34 bytes when you put that onto LTE going over UDP. Now, bearing in mind those two bearers are inherently secured. When you then compare the next level with security included, then you're talking about an inflation factor of 473 times. So a massive difference there just on adding security to the protocol that you've chosen. So now I'll hand you back over to Neil. He'll talk to you about how some of our customers with the different use cases that we mentioned earlier have looked at that, taken those considerations into account, and the solutions that they've come up with.
Cheers, Nick. Thanks. So as we said at the start, we showed kind of 3 objects or 3 devices, and now we're, if you like, tell the story behind them, about what's in them and how they're operating to solve the business challenges that they were designed for. Starting with cargo tracking, which is very common. A lot of our customers are obviously building, tracking-based devices for telematics and supply chain, etc., as we said at the start. This particular, if you like, use case is with our customer or partner in Spain, in Europe, and they originally were working with their customers needed a reliable tracking device that could operate for up to 10 years in the field, depending on the use case. So they built a device that could be configured with different frequencies of communication, as I say, lasting up to around 10 years. I think the majority of the use cases are probably around 3 to 5. But this is a design house and an ODM, so they're manufacturing these devices and they're selling them to systems integrators and end customers who want to configure their usage and then get the data from them into their cloud relatively easy. And part of the remit here is obviously, apart from the power consumption or the life they have to last in the field, there's obviously a target as well on the BOM cost of what could they be, developed for at a particular, volume. So that was the original conversation. And then obviously, as we were working with this partner, they understood from their customers that they didn't just want a device with a SIM tray where the customer is left to choose what maybe mobile operator they would be using, and then all the other components needed for getting that data from the carrier and then into the cloud and manipulated, etc. They really wanted to offer a one-stop solution, as Patty said at the start, which just offered connectivity out of the box or data into the cloud out of the box. So they wanted a predictably priced kind of operating model or a service behind this, as making it a kind of a unique offering. And of course, the bidirectional communication was important because people wanted to reconfigure these depending on those use cases. The second part of the challenge as well is when we look beyond just the PCB and what's on it and the various components, the actual data itself needed to be ideally meaningfully ingested into the enterprise platform. So no one really wanted to take, or they would take responsibility, but they didn't necessarily want the overhead of having to find some DevOps guys or some guys to maybe run some web services in order to take the data from those devices. And as Nick just explained, they're publishing MQTT. So that means there would need to be a broker involved to receive that information, and then they would need to configure something on their side to subscribe and then manipulate the data so it's formatted ready for Cumulosity, which is Software AG's platform, or Watson or AWS, etc. So again, part of the solution that we brought to this this customer was we take care of all of that. It's not just about the connectivity, it's about also getting the data into a packaged format that's consumable easily and simply by the end customer. So when we go back to look at just the radio options, Googling low power wide area, you'll more than likely find these contenders, fighting for the top spot somewhere in Google, either directly or indirectly through the partners or the networks that are using these technologies. And so these are kind of the most common. There are more, we appreciate, but these are the three we see most commonly, and the ones we discuss with customers to see whether they really suit their requirements. And for this particular use case, as one could imagine, Sigfox isn't necessarily the right fit. It has its place, in the IoT market, but certainly isn't for this type of flexible, tracking of cargo in trucks and products and what have you. And then LoRaWAN itself, again, even though there's a number of public LoRaWAN networks now available, usually in parallel with often a carrier themselves, the roaming capability that these products could be sent anywhere in the world. Are the networks ubiquitous? Are they available everywhere? Do I need different radios inside depending on which region of the world they're working on? There is some challenges there with that type of application. They're obviously fantastic for other use cases. So for this particular one, it doesn't fit. And then you're led to the licensed low power options with NB-IoT, which is popular in Europe, and we have LTM now growing in Europe. And I know many of you are from North America today as well. So obviously, LTM is going to be a driving option in that part of the world as well. But again, we're talking about a global option here. And so when we start looking at these, there are some challenges. You would be led to think, well, cellular gives me that global footprint, which is great. Do all of the carriers around the world offer me, or can I obtain a roaming, SIM, for example, that would give me access to all of those areas of the world? They are coming. We are seeing an increase in roaming agreements now for LTE-M between carriers, which is great. And there is some NB movement as well. But it's in its infancy. So again, for a solution that's going to last today for 3-5 years maybe, and we want to roll the products now, these aren't necessarily the best fits now. Having that kind of backup or backup option is important. And there's other challenges that we've discovered. Nick, maybe you can provide some words as well on the low power challenges we find in some of those network instances with this as well.
Yeah, for sure. So as you're probably aware, these low power networks bring a number of power saving modes that you can enable on the modem, PSM and EDRX, which are designed to help you optimize your power consumption. But a couple of things that we've discovered and that need to be borne in mind when you're designing the solution is exactly how those things are going to work on the networks. Now, with the power saving modes, you can make a request of your timers to the network, but it is just that, just a request, and the network has no obligation to honor that request. And actually, the networks implement their own timers based on their own needs. So you could find that a setup that you had in your lab on a network that had friendly timers for what you want to do that you thought was going to give you a 5-year battery life. You could put that out in a field on a different network, and suddenly your battery life's been reduced to 1 year purely because of the way that these timers are working. So it's very difficult for you as the designer of the product to reliably factor those things in unless you know exactly where that device is going to be used and the network that it's going to run on. So if you know that you're doing a water metering solution that's going to run in a particular city, then it's obviously quite easy for you to know the network that you'll be on and do those calculations and have that reliable information. But for everyone else, it's a bit of a minefield and can be quite complex to work out. So you may well find that the power savings that you think you can gain from these low power networks are actually not that significant, and maybe the 2G and Cat1 LTE networks will give you similar results, especially when combined with a carefully considered protocol as well.
Cheers, Nick. Absolutely, and that kind of leads to maybe the conclusion of where the reality check was for this particular customer. Today, yes, 2G is still viable in many territories. Obviously, in the US and other parts of the world, it's starting to, be sunset. I think in Europe, we're looking around 2030, possibly for that sunset. There's a range of solutions that are still needed by government authorities for 2G and what have you. But over time, it will, be refarmed. We will see a sunset. We see 3G really moving much faster from that perspective. So again, this customer is serving transport companies and those that are mostly in Europe. So 2G fits pretty well. However, knowing that the customers will want to have product coming to the US and other markets, then they need to adopt and future-proof slightly. So again, having a pin-compatible module where you've got the LTE-M as well will give that capability. So this is the strategy here. The original product was at 2G only and is still being sold in volume. But there's the LTE-M variant flowing behind, and that's really to give the connectivity. I don't think the design necessarily will worry too much around PSM or redirects. It's very much about continuing to adopt and use the MQTT-SN protocol to provide the driving savings or the main savings from a power perspective. So the other angle here, which is very appealing, is again, we're taking care of all this other stuff in this grey box, if you will. Yes, there is the ability to enable a device to confidently roam around the world and use networks in a very power efficient fashion, regardless of really what the bearer is. But there's that second component, which is solving the problem of organizing and preparing the data and getting it into the enterprise and back again. So again, bi-directionality, is important for this type of solution. So again, that was all appealing, very appealing to this customer, and it makes them easy to sell these products that are almost plug and play for their customers. The other aspect here is the commercial model that we offer for our services is pay as you use or pay as you go. So again, that fits really well with many of these applications where products might not be used straight away. They could sit in warehouses or they go out for a tracking, expedition, and then they come back and they need to be, put on ice again for a while before they're reused. And again, having that flexibility is really important when you start looking at the total cost of ownership for an IoT solution. So again, there's a number of these really interesting angles. It's the power saving, it's the commercial angle. We spend a lot of time thinking about how can IoT be simplified, and certainly in the when we start looking at the IoT constrained requirements that many customers require. And as we mentioned, the pre-packaging, we have many of you may have seen the ThingStream platform, the ublox ThingStream platform, and in there we have these pre-built connectors to make it easy to get the data into the cloud. So they're all useful tools. And as I said earlier, this is all, when we talk about connectivity, really connectivity is just one part of the overall solution. And it's all these other components that are often not considered when designing just a device. We'll make it someone else's part of the process to worry about those components. But if you think of them all as a whole, then the whole solution is more efficient, both from a battery perspective and commercially for the end customer. Similarly for pet tracking. So again, our customer in the UK, Pawtrack, their business challenge is they're trying to sell a very specific tracker. It's very different. Cat tracking is different to a dog tracking device. There's different use cases for why you need to track them, and it's hugely popular. I'm a dog owner, so I wasn't familiar that this was a thing, but it is, and there's many customers around the world who require or would like this type of product. So again, this is a fantastic opportunity from a business perspective to sell them online. E-commerce is global, so just open the doors and allow customers to come and buy these devices and download the applications and subscribe to the value-added services that are provided. But again, here's some new challenges. Now we've got a physical, the dimensions are constraining maybe the design of the PCB. So now we need to be smart about, well, what modems or what components do we choose to go on here? So you can only imagine the many hours spent thinking about this. But from a business perspective, ideally, it would be great to have a single SKU that could just ship from the website and no one needs to worry. Someone can just pull a tab, download an app, and start using. So that was the kind of business challenge. And obviously, power is important. Yes, we're more likely going to recharge these on a more frequent basis because they're a consumable in many respects. So we're all aware of putting these things on wireless charging pads. That works. But again, we don't want to be doing it all the time, like every day. We need some longevity. So power efficiency is important here as well. So again, when we start thinking about, great, well, I'm now going to design this device and need to sell it around the world. Similarly, this isn't an application necessarily right for Sigfox, whereas maybe an environmental monitoring solution, across Europe would be. So again, it's the strategy is let's find something that will work globally in this instance. Similarly, LoRaWAN wouldn't necessarily be right for the similar reasons. And then the low power cellular variants aren't quite right. They're almost there. If we had the patchwork of roaming available globally from us or anyone who provides a solution with a SIM in, then this would be a more widespread solution, and it is coming, but it's taking time. So again, how do we get the low power variant? How do we make this kind of perfect device? And as Nick mentioned, there's some challenges from that perspective. So again, the solution here is really just being pragmatic. There has to be a 2 SKU solution because of the size of the PCB. There's only so many things that we can actually get on board that device. So having a 2 SKU option, a 2G for rest of world, which is okay for now, and whilst we still are waiting for the roaming to evolve and mature, that's fine. But specifically for the North American market, there's a different variant because that we cannot rely on 2G there, because obviously I think it's December 2022, I believe, T-Mobile have announced they will pull the plug finally on 2G. So again, we can't rely or allow our business to be kind of run if we're at risk from running on 2G. But again, all the other benefits, again, in organizations where there's not a large web development team or a huge number of web staff who can, maintain and run the cloud systems, having everything taken care of at a fixed price and predictable, regardless of which SKU I'm selling, wherever in the world, based on just my MQTT consumption, that's really appealing. I can actually now plan my business and my cost scale with my success, and that's part of what's driving the way in which we're packaging some of these solutions. And the final use case, just to show a kind of very different connectivity strategy. And again, this is a fantastic product offering. This is a partner of ours in South Africa, Lumkani, and they are providing fire safety technology or products that have to be really simple to use. They have to be battery powered because there is no power running to the townships in parts of the world where they're targeting this solution. And again, there's particular different continents we're selling these products, but what effectively the challenge is how do we mesh hundreds of battery powered smoke alarms or fire alarms to this gateway that I showed you earlier in this presentation in a way that it can last for a long time in the field. We don't need to go back and revisit and find that gateway and have to recharge it, and also make it really efficient in terms of getting that data into their cloud. So you can see there's a few interesting challenges here due simply to the lack of power, and also from some of the geographical challenges from this type of application. So again, as we look at the analysis of obviously the key contenders here, well, in South Africa, Sigfox has good coverage. There is a good network there from what we hear from our customers and partners. But in the other territories, in the other countries around the world where we're targeting, again, there may not be, or there certainly wasn't at the time of development, the option of having that network there for the fire alerting. And this is basically the application, if I touch on that, is whereas we, if someone detects a fire in their home, they would hit the button, or the fire alarm itself would fire off, and the mesh wakes up, and all the community are alerted and directed to where that fire is. So it's kind of a community safety device, but these devices will communicate with the gateways, and the gateways get the data into the cloud from the monitoring services and all the other enterprise services that are offered on top of this. LoRaWAN therefore isn't really practical. No one's built yet a LoRaWAN in these particular, or a public available network in these areas, though the technology could fit. And again, there's certainly not going to be any near-term low power cellular coverage here. So again, it's interesting. We have now, this low power protocol preserving this battery on the gateway for a really long time. And our options are really, from the territories around the world this customer wants to operate, is going to be 2G and LTE. That's really the two main options. But if you can think, they are now behaving from a power perspective very similar to what we'd expect from an LTE-M modem. It makes it quite compelling, because it's the cellular module, it's the power saving features that make them attractive, and obviously cost as well. But if you can still have a solution that works globally and still gives you a similar power budget, that's exciting for many businesses that didn't necessarily know that this type of capability was possible. So again, here a similar kind of story from what you've seen before here. So we're not advocating 2G as is the solution going forward. It's great for now for certain use cases, and we clearly recognise LTE-M as well it's moving to be the next kind of roaming low power capable cellular offering as well. NB-IoT we see as being excellent, and we see that more being used in domestic or municipal kind of applications as well. So when considering IoT and your connectivity options, the point we're trying to make is think about the biggest market your customer could sell to, and how do we pick the right kind of connectivity and the additional components to make this a cost-effective implementation. So drawing a conclusion just on these case studies and what you've heard, we just see that the connectivity piece alone is just one part of the overall puzzle. It's one part of the solution. There are many other components that need to be considered, and we're trying to present here that actually you can consider many of them all at once through looking at the thing stream, or the u-blox thing stream technology that we have. Protocol, as Nick's pointed out, is really important, and we've got more measurements and kind of evidence around the different types of power usage. And then the other component is very much when you want to scale these solutions, when you've got thousands, tens of thousands of things, the operational cost of managing all that data will be significant. And so again, by using the, a smart protocol that's built for one-to-many communication, such as these publish subscribe options, such as MQTT, that later will pay dividends in the cost of operating your IoT solutions. So hopefully that's useful information we've shared, and would be keen to look at any of your questions that have come across. Patty, I've lost my cursor, so I can't actually open up my questions bar. Maybe you can lead us.
Yep, no problem. Let's read it aloud here. So it might be more of a comment. NB-IoT is ideal solution for smoke detector due to the RRC release power consumption would be much lower. RRC feature releasing from the network. Okay, good point, Robert. There's no other questions here.
As I just coming to that point, Patty. So yes, it's true, but you still have to take into account a number of things when you're looking at how RRC works and what that really means in terms of your power budget. And you also need to consider that NB-IoT is still not that widely available. So if you know that your smoke alarm's going into a very specific location, and you know the network it's going to go onto, then you can factor in RRC and some of the other power saving mechanisms to develop that solution. But if you're looking for something which needs to be able to just roll out more widely without having to think about exactly where it's going to wind up, then NB-IoT is probably not the solution just yet. Not to say that it won't be one day, but that's probably a few years away just yet. I don't think there are any other questions at the moment.
Okay. Patty?
Yeah, another question just came in about the power saving modes on the network. So Martin asks, do we have to rely on the network provided timer? Can we set up a longer PSM interval and wake the modem up earlier using the external processor and benefit from the instantly logged in state? Not necessarily, Martin. So it will depend on how the network wants to handle PSM. You might choose a longer PSM interval, but the network might not support it. And especially when, again, when you're roaming, while PSM may be available if you have a direct relationship with the operator, and you're on a home network SIM. If you're on a roaming SIM, these power saving modes may not even be made available. They're not always switched on for roaming customers, and may also not have the same timers. So it's not as easy as that to work out. There's a lot of technicalities that you need to take into account with these modes. A couple more questions just popping in. So Robert's asking, does our SIM provide 2G and Cat-M connectivity? Many MNOs provide SIM only for Cat-M without 2G support. Yes, that's a good question, Robert. So by our SIM, he's referring to the blox MQTT Anywhere SIM that you can see on the screen there. And the answer is yes. So that the roaming profile that's enabled on those SIMs is active for 2G, 3G, 4G, Cat-M and NB-IoT. So you don't need to make any changes to the SIM card. It will just roam onto the network that's available wherever it wakes up. So if there is an NB network there or a Cat-M network there, and your hardware is capable, then the SIM will roam onto it. You don't need to change anything at the sim level.
Okay, there's no other questions in the panel here, so continue to add them if you think of something. And meanwhile, I think Neil and Nick, I can just chat about what we have available and coming up next. So shown here on the screen, after the webinar, we want to send you an email and invite you to try this out. Try out the MQTT Anywhere Sim and unlock that power of the protocol. So we have a little trial offer. There's a quick start guide included. It's pretty easy steps. So please, I invite you to click and experience. And then the other thing we have coming up is another webinar. Our next webinar is May 11th, and we invite you to register. So if you're interested in power savings, you'll really want to come to this one. This is about cloud-based positioning. So doing the measurements and sending measurements to the cloud and calculating positions and using that information in the cloud versus on device can really take your power savings even further as compared to a more traditional GNSS power savings approaches. So be sure to sign up and register for this upcoming webinar. All right, with that, I'll check the question panel again, and I see nothing further. Going. All right, with that, guys, I think we've concluded our webinar, and thank you very much for your attention, and we wish you a good day.
Thank you.
Thanks, everyone.